Welcome back to another lesson. In this one, we're looking at Group 0 noble gases. Now, it's an important topic because it links in with questions to do with the general trends down the group, the reactivity of our Group 0 elements, their various properties, and then lastly, their applications in the real world. Our Group 0 elements are found at the end of the periodic table, highlighted there in yellow. Let's take a closer look, and starting off, we'll look at the physical properties, where we'll focus on the melting and the boiling points. So, as we go down the group, the atomic radius increases. This just means the atoms actually get bigger, with helium being the smallest and radon at the end being the largest. And because they're getting larger, there'll be more intermolecular forces between the individual atoms. This means there'll be more energy required in order to break them apart. Therefore, as you go down the group, you're going to have a higher melting point and boiling point. Next up is the density of our Group 0 elements. And again, this is going to increase as we go down the group. And the reason for this is because there's more matter per unit of space. And we can take a closer look at this. Again, starting off with helium here, you can see the space it occupies per 2 atoms. And as we move down the group to neon, the atoms are getting larger, so they're taking up more of the same space. They're becoming more dense. And the last one we'll show here is argon, taking up the most space out of the 3 that we've gone through. And this pattern continues down the group. And we can see here as a final comparison with the amount of free space versus the amount of space occupied by the atoms. As for the chemical properties, it will be nice and easy. Our Group 0 elements are very unreactive. And we can look at the atomic trends to help us explain this. So we'll focus on the first 3. Helium here has 2 electrons, and we can tell that from its proton number, and those occupy the first electron shell. And then we have 10 for neon and 18 for argon. And we can see here with each of these examples and the rest of our Group 0 elements, their outer shell electrons are full. They're complete. And as we go down the group, we're adding 1 electron shell from one element to another. Okay, let's take this to help us explain the reactivity. And quite simply, as I've stated before, Group 0 elements are unreactive due to their full outer shell of electrons, which means they don't need to gain or lose electrons in order to complete their shell. And that's it for that one. Right, their uses. Helium you'll find in balloons and airships, and this is due to its density being less than air, allowing it to float. And then we have neon, quite simply found in neon lights. And lastly, argon, which will form a gas shield when used in things like welding to protect the user from the high heat. Okay, let's bring all of that together. Here's your first past paper question. Take the next minute to work through this. Let's see how we've done. Here's the answer to the question. And as we've stated before, noble gases have an increasing boiling point as we go down the group due to the increase in the intermolecular forces between the atoms. And your last past paper question of the lesson. Again, take the next minute to work through this one. And if you finish early, skip ahead. Let's see how we've done. Now, neon has a full outer shell of electron, which means it's unreactive because it doesn't need to gain or lose electrons. Right, let's summarize. All of our group 7 elements are unreactive gases, and they all have a full outer shell of electron, which means they don't need to gain or lose electrons. And lastly, it's the memorization of those useful applications of the noble gases. In the next lesson, we'll be looking at metals and non-metals. And don't forget to like, comment, and subscribe. I'll see you in the next one.